Hi there dear viewers, welcome to Brainiac. Today we will be watching how to balance redox reactions. If you are ready, let's go into the video. In this video, we will learn about two different methods of balancing redox reactions. When I say redox, it means oxidation and reduction reactions. To balance a redox reaction, there are two different methods. The first one is the oxidation number based method, and the second one is the half ionic reaction method. For all those who need a recap, this is what a redox reaction is. Observe the following. So this is what a redox reaction looks like. So, before we go into the half ionic equation method, let's try to balance this equation in the oxidation number based method. So, the first step would be to identify the elements whose oxidation number gets changed during the reaction and equalize diatom numbers in reactants and product sides. As per above statement, we have to recognize the elements which is going to oxidize or reduce in the following reaction. So, the oxidation numbers will be 7, 'So, the next step would be to equalize the diatom numbers in the reactant and product sides. We balance the number of reactants and products in both sides like we do for other equations. So here the only balancing required is in carbon dioxide. So let me do it. And there you go. And it's done. So after that we are in another step to balance the oxidation numbers too. Here +3 is the oxidation number of one carbon atom. Since there are two carbon atoms present here, we have to multiply the oxidation number by 2. So the oxidation number is transformed into +6. We do the same to carbon dioxide too. Here the oxidation number of one element is +4, and since there are two atoms, we have to multiply this number by 2, and therefore it gets transformed to +8. And there you go, our first step is done. So what is the second step? So the second step would be oxidation number changes are to be calculated. This is a very simple thing. It's basic mathematics. Observe carefully. When doing this step, we always have to consider relative elements. So MnO4- is relative to Mn2+, and C2O42- is relative to 2 carbon dioxide, and thus we have to calculate the oxidation number differences in these pairs. So if we consider the first pair consisting MnO4- and Mn2+, and then when we consider the difference in between them, it would be +2 minus +7, and then the oxidation number change would be -5. Do the same for the other side. Pause the video and calculate, and come up with the answer of the oxidation number change. If you have done correctly, +8 minus +6, and you would have got the answer as +2. And that's the end of step number 2. The third step would be oxidation number changes are equalized by multiplying them with suitable coefficients. In same coefficients, appropriate reactants or products are also multiplied. So here, let us observe the oxidation number changes in these two pairs. In this step, we get the common factors of -5 and +2 and thus use them to equalize the coefficients. So I do a simple adjustment by multiplying -5 by 2 and +2 by 5. Thus when doing that, we also multiply the elements associated with oxidation number changes. So we multiply MnO4- by 2 and Mn2 plus by 2. And we do the same for the other pair, where we multiply this by 5 and this also by 5. And the resultant reaction would be we're not done yet. There are a few more steps to go. Time for step number 4. Time for step number 4. In this step, we balance the charges. If the resultant medium is acidic, then H plus is added to the less positive side. Or in other words, the more negative side. If the medium results in a basic medium, then OH minus added to the less negative side, or in other words, the more positive side. If the resultant medium is neutral, then we add H plus or OH minus. To which side we add it? To the less positive or more negative, or less negative or more positive? No, we add it to the product side. So these are the basic rules of the 4th step. And then let's get back to our buddy here, the reaction which we almost completed with the 3rd step. And as I said before, it's time for us to balance the charges. If you observe this resultant is an acidic medium. So if you can correctly remember, we add H plus to the less positive side if the resultant medium is acidic. So let us consider what is the less positive side here. For that purpose, we have to add the charges. This 0 appears for carbon dioxide. The carbon dioxide has no charge, so the charge would be 0. So what is the less positive side here? Obviously, this. So what do we do? As per the rules, we add H plus to the less positive side to make the charges equal. So, what is the number to be added with -12 to equalize to +4? Obviously, +16. Then The rest is simple. You have to add 16H+. Sorry if my handwriting is too small. You have to add 16H+ to the reactant side to equalize the charges. The next step would be the oxygen balancing step. Here, the amount of oxygen is calculated on both sides, and then to equalize the amount of oxygen, water is added. So let us calculate how many water is in the reactant side. So we have 8 here, and then we have 20 here, which gives us 28 oxygen. And then on this side we have only 20 oxygen. So what can we do? Where should we add water? Is it to the reactant side or the product side? Of course, we had to add water to the product side. So, how many oxygen molecules are missing here? 8 is missing. So we add 8 water. There you go. Now we have finally obtained the balanced redox reaction. So, earlier we had MnO4- plus C2O42- to 2Mn2 plus carbon dioxide. Now the complete balanced equation is here. Well, now it's time to move to our second method. Let's see what that is. Let us now move on to the half ionic equation method. For that purpose, we will use the same reaction. As the above method too, this method also consists of 5 steps. Among them, let's now go to the first method. The first method would be oxidation and reduction reactions are separately written, and the element atoms whose oxidation number are changed are equalized in either sides. As I said earlier, relative reactants to the relative products. Don't forget to write the oxidation number in all cases. And there you go. We have separately written these reactions, and there is no need of equalizing the elements because it's already balanced. And step 2 will be oxidation numbers are balanced by adding electrons. Electrons are added to more positive or less negative side. This rings a bell, right? Like we used to balance charges earlier. So here we add electrons to more positive side, which also means less negative. First of all, before adding the electrons, let us balance the oxidation numbers according to the number of elements as we did in the first method. So if we consider the first reaction, the more positive side is +7. So to equalize to +2, we have to reduce 5 from 7. In that case, we add 5 electrons to the reactant side. Get it, people? So pause the video and determine to which side we have to add electrons in the second reaction and how many electrons should we add. If your guesses are correct, we should add electrons to the carbon dioxide or the product side, because that is the more positive and less negative side. We have to add 2 electrons to equalize +8 to +6. And now let's move on to step number 3. Here, this is the step to balance charges. As per above method, in acidic medium, H plus is added to less positive or more negative side, and in basic medium, OH minus is added to more positive or less negative side, and then in neutral medium, either H plus or OH minus is added to the product side as per above method. So, since we are using the previous equation in this case too, we already know that this reaction is acidic. And if it is acidic, we have to add H plus to the less positive side to balance the charges. But first, let us calculate the charges in both instances. 5 plus minus 1. In this reaction, the charges are already balanced and this is good to go. So we are having a need to balance the first reaction. Let's see how it is done. So to balance the above charge, we had 8H plus here. By adding 8H plus, we subtract, or rather, we add plus 8 to minus 6, thus equalizing the charges. Plus 2 equal to plus 2. And that's the end of step 3. Let's move on to step 4. This step, we have to balance the oxygen. For that purpose, water is added to the less oxygen side as we did before. Before continuing this step, let us write the other equation here too. So, now let us calculate how many oxygen is on the either sides of the first equation. Let's say there are 4 oxygens here and there is 0 here. So we have to add 4 water to the product side. In the same way, we find the number of oxygen in the bottom reaction too. So here the oxygen is 4 and here also it's 4. Thus, these both are balanced. And let's move on to the final step. Here, oxidation and reduction reactions are signalized, so that electrons gained by reduction reaction should be equal to the electrons liberated by oxidation reaction, so that equations are multiplied in suitable coefficients to equalize electrons and combine it. So as we did in the above method, to equalize the differences of oxidation numbers, we have to multiply both equations by the common factors. So, as per above rules, we multiply the first equation by 2 and we add it with the second equation, which is multiplied by 5. As a result of the above addition, the following equation will be obtained. So, as basic rules of mathematics, we can cancel off equal terms in both sides. So 10 electrons will be cancelled off with 10 electrons. And then this would be the final balanced equation. Check the answer with the before method. The both methods are very easy. You can either choose one or you can choose what is easier for you. The first one might be easier for some, or the second one will be easier for some. It's a 50% probability of choosing between these two methods. So choose wisely. Wise decisions can help you to score more in your exams or other areas. So until we meet in another video, stay subscribed to Brainiac and keep liking and watching our videos, cause learning is fun. Catch you guys on another video related to physics. Until then, bye bye.